Okay, we're going to be reviewing some more properties of objects and looking at mass, weight, density, volume, and surface area. And we have a couple of objects here, and the objects are drawn on grid paper. So you can see that the grid paper is measured in quarter-inch increments. So if I were measuring this face, I would count 1, 2, 3, 4, 5. So that's 5 units times a quarter of an inch. That means this side right here is 1.25 inches long. Okay. Using those measurements, you're going to calculate the volume of the part. Okay. And so remember, we have formulas for volume on our formula sheet. And looking at this, it's not a regular prism, but you can divide it up into regular prisms. So I have a rectangular prism here, here, and here. So you can add up the volume of the individual components to get the total volume of the part. And you will do similar operations to get the surface area. You can add up the surface area of each individual face to get total surface area. Now, we also have questions about weight and density. Okay? Remember, mass density and weight density are two different things. Mass is the amount of material in a given volume, and weight is the effect of gravity on that mass. So if we're looking at mass density and weight density, weight density is noted as D sub W, and that's weight divided by volume. Mass density is denoted as D sub M, and that's mass over volume. So remember, mass and weight are not interchangeable, okay? But when we deal with weight density, we're typically dealing with pounds per cubic inch. And when we deal with mass density, we're typically dealing with grams per cubic centimeter. When right here, you're given a problem where you have measurements in standard units, but you're given density in metric units, okay? So we need to have some type of conversion. We either need to convert the linear measurement to metric or convert this mass density over to weight density, okay? But since mass and weight are not interchangeable, we do have a workaround for converting mass density to weight density, and that is summarized in this line right here. So if we have, for example, a weight density of 1 pound per cubic inch, and we want to convert that to mass density, this is what 1 pound per cubic inch equals. However, to get there, if you remember our conversion example, we have given units times desired over given, and then desired cancels out. So if we have a pound per cubic inch, we want to convert that. We're going to say for conversion purposes that 1 kilogram is 2.2 pounds of mass, even though we know that the unit for mass in standard is actually the slug. But if we convert that over, we can say pounds of mass. 1 kilogram is 2.2 pounds of mass. And then we cancel out pounds mass. We can cancel out kilograms. Okay, we're converting from grams to kilograms. And then we want to cancel out cubic inches. So 1 inch cubed is 2.54 centimeters cubed. Okay, so we cancel pounds, we cancel kilograms, we cancel cubic inches, and we're left with cubic centimeters. Okay, so we have grams per cubic centimeters. So 1 pound per cubic inch is equal to 27.68 grams per cubic centimeter. So this is weight density converted to an equivalent of mass density. So once you have determined volume, you can convert the density of this material from mass density to weight density, show your work, including your units and conversion factors. And then once you know the volume, and you have volume in either in standard units, and then you have density and weight density, which is standard units, you can calculate the weight of the object. In this second one, we also have 0.25 inch grid spacing. We have density in mass density, 1 gram per cubic centimeter. So we're going to calculate volume in cubic inches. Then we're going to calculate the weight again. And you're going to use that conversion for mass density and weight density. So 1 pound per cubic inch equals 27.68 grams per cubic centimeter. Okay? And this is your conversion right there. A kilogram is 2.2 pounds of mass. Okay? And you know mass is volume times mass density. Weight is mass times gravity. And weight is volume times weight density. Okay? We're going to work out these problems in your engineering notebooks, showing all your steps and your calculations and correct units. You can create these models in Fusion to check your work, so you can use Fusion to check the volume and check the surface area, and you can assign a material that has this same mass density to check your work. So you can use that as your calculator to verify your answer, but I want to have you show your steps to complete each problem all the way with the correct units and correct answer.